Hello, beautifuls. This is Atleen, and I'm coming to you with another video. Today, we will be discussing the network basics, the OSI model, Open Systems Interconnect model. Technically, it is the ISO model, which is the International Standards Organization. Well, you can think of the OSI model as a folder, like a file folder system, which is a place where you got a folder and you're going to place similar documents in that folder. So you got another folder for another type of document. Well, this is just an organizational system for all the things happening on your network, whether it's a particular function or a particular hardware. There are different functions at different network things, hardware, software play. There's also the TCP model. So as you can see, I'm showing you the TCP model and the OSI model. So we're going to do a comparison today. And this is located in the Window Odom book, Ccna⁶ And you can find this information, and it's located in Volume 1 and Volume 2 of the Window Odom. So right now I will read. So this is Ccna⁶ Volume 2, Window Odom. And you can also find the OSI model, TCP model in comparison in Volume 1 as well, Window Odom, Ccna⁶ Introduction to TCP IP Transport and Applications. And this is in Chapter 1, Volume 2. Okay, so I will read. Get it in focus. Okay. So the Ccna exam, it focuses mostly on functions at the lower layers of TCP IP, which define how IP networks can send IP packets from host to host using LANs and WANs. And this chapter explains the basics of a few topics that receive less attention on exams. The TCP IP transport layer and the TCP IP applications layer. The functions of these higher layers play a big role in real TCP IP networks. Additionally, many of the security topics in Part 1 and 2 of this book and some of the IP services topics in Part 3 require you know the basics of how the transport and application layers of TCP IP work. And this chapter does serve as an introduction. What we will go over is basics of the OSI model in comparison to the TCP IP model. So in this video, for the Ccna, we are focusing on the bottom 4 layers, which is what I just read, which is transport, network, data link, and physical. Go over here, it's the same in the TCP as the OSI. Transport, network, data link, and physical. A good acronym to remember the OSI model is please, from the bottom to the top, please do not throw sausage pizza away. The P is for physical, the D is for data link layer, N is for network, T is for transport, S is for session, P is for presentation, and A is for application. Now the physical layer is where the bits are happening, where we are physically getting information from point A to point B. And it might be electrical signal over a wire, or it might be a photon over a fiber optic cable, or it might be a radio wave from an access point. But it's the way our bits actually travel. They actually travel is our cable up a data link layer. And I suggest for you to write this down. Data link layer is the MAC address, and it's something that is categorized here also at layer 2. Data link. The MAC address stays here as well. So that's something that is good to learn and write down. Now the switch keeps track of where these layers, the layer 2 addresses live, and make that CAM table, content addressable memory, CAM. That MAC addresses is located here at layer 2, data link layer. A router lives at the network layer, layer 3. And this is where we're making all the decisions, not based on physical MAC addresses that are burned into our devices at the time of manufacturing, the manufacturer, but at the network layer, we have routers that are making decisions based on, remember in the video that I discussed about the street analogy, where they are making forwarding decisions based on network addresses, and these are not physically burned in somewhere, as we discussed with the MAC address at the manufacturer, but these are logical addresses. And it's addresses that we come up with that we are assigned. So it makes decisions based on these logical addresses. Now the transport layer, layer 4, that's where we start to actually take the raw data and start wrapping it. And there are 2 forms of transport protocols at this layer. UDP, unreliable transport protocol, and there's TCP, transmission control protocol, which is very concerned about your data getting wherever it needs to be safely. In contrast, UDP is unreliable and it doesn't have an acknowledgement, whereas TCP has an acknowledgement that you received the data, also known as the ACK. We'll go into that later into the chapter. Once we start reading, in detail, this is just the foundations, the basics. So if you do not acknowledge that, hey, I got it, it's going to say must have been lost in transit. So let me send it again. So TCP is considered a reliable transport protocol, and a UDP is considered to be unreliable transport protocol. The reason I say that UDP is unreliable is because it doesn't wait, like I said earlier, it doesn't wait for an acknowledgement. And of course, you're probably asking, well, why do we use it if it's not reliable? And the reason why we do use it as an unreliable protocol is because it's due to overhead, which is associated with acknowledgement. So for things like voice, for example, live streams, we send our voice streams and we send them using UDP, and it cuts down on overhead. And if we did drop a video frame or an audio frame and then we dropped it, we better play it back later on in the conversation, and it would be really, really ridiculous looking. It looks silly. So there is a place for both of these, UDP and TCP, as far as learning the OSI model and the TCP IP model. They both play a role. They both have good benefits in it. So there is a place for both, okay? So, and at the session layer, which is layer 5, this is where we set up, maintain, tear down sessions. The next is the presentation layer. And this is how we encode our data, the format of it. For example, if it's an ASCII, if it's like rich text format, or if it's a JPEG, or if it's encrypted, that's a way of formatting our data. And that's the presentation. Finally, at layer 7, it provides protocols that allows software to send and receive information and present meaningful data to users. For example, secure shell lives here. Okay, well, we're not going to go over 14 minutes is the goal. And what we're going to do is read some more tomorrow. I just want to go over the basics today. So thank you for listening. Thank you for watching. And I wish you well with the CCNA certification.